Hello everyone, welcome back to our channel. In this C programming playlist, in the previous video we have thought about the operators arithmetic operators and relational operators. So in this video we are going to see about the remaining types of operator, that is conditional and logical. So before moving to the operators, we are just going to learn about the scanners because it is important to get the input from the user and we using it. So now we see about scanf and how it is functioning. Okay. So I'm creating a new file. Scanf. Then our syntax stdio.h. So terminating the is important, right? So what is basically scanf? Scanf means it is a function to get the input from the user. Okay. Basically we want to take user input, right? So we are using scanf. So it is from the library of stdio. Okay, std standard input output library. So from that library we are going to take the scanf function to get the user input from the user. Okay, so basically scanf is a formatted standard input to get the user input from the user. Okay, so syntax for scanf is scanf, format specifier, then variable 1, then variable 2, and so on. We can give n number of variable, and here you want to give n number of specifier. If you how many variables you want to get the user input, that much format specifier you want to insert in it. Okay, so what does this mean? What does this symbol mean? Ampersand symbol, right? So this ampersand symbol represent the address of the variable. It represents the address of the variable, right? So it means if we are giving like int n, okay, just consider we are giving one int n and we are getting scanf. For int, what is our format specifier? We already taught, right? For int, it is %d, right? So %d, comma, ampersand symbol n. So what here happening? So it is specifying that the input is integer. Okay, this format specifier, this %d specify, it is now this line is getting integer as input. Okay, so here we are giving this format specifier to give this type of data type I am going to get as an input. So here this %d will denotes for an integer, right? So here and n means while you using this ampersand symbol, it represents the address of the variable. So it will in the nth, that means in the memory location we have n for nth variable for some places we have, right? We have declared here, we initialize n here. So when we initialize one variable, it will have some space in our memory. So this ampersand symbol denotes that place and it will assign the value what we are giving in the scanner. See, if I while uh, while running the program, the cursor will ask the input rate. So if I give 10 in the memory location of n, the 10 will be stored there. Okay. So now let me run and see. See here it is asking input. So if I give 10, 10 will be stored in the n. Wait, let me print it and see. Printer, what is the percent int for format specifier? Percentage D, comma, what is variable we are going to print? N, right? For printing, we don't need ampersand symbol. For using scanf only, we want to use ampersand symbol. Because we are getting for this variable, we want to denote it. Okay. For which variable I am assigning, for which variable I am giving this input, we want to denote that. So only we are using ampersand symbol in scanf and not in printf. So here what will print? If for my n I give 20, here it will print 20. So we just run this. The cursor is asking for input. Now I given 10. Then press enter. The 10 is printed, right? Okay. You can give multiple number of scanf. Okay. See, we can initialize variable like this. In the same line, if you want to initialize 3 variable, you can initialize like this also. Okay. Then if I want to get 3 input means scanf integer, right? So percentage D and address of what we have next variable m. Then scanf percentage D. Then which variable? Ampersand k, right? So now we are getting 3 variables input, right? So we want to print 3 variables, right? So I just copy this. So here for m we are getting k, we are going to print it. So I just give here a space so that you can clarify which variables value which is. So in our output screen what will happen? There will be 3 times we want to give input. 10, 20, 30, right? See 10, 20, 30. Here I have given 10, then here I have given for m 20, then here I have given k for 30. So in printf, for n it will print 10 and for m it will print 20 and for k it will print 30. Okay. So this is how we are going to use the scanf and get the input and we have print it. So here we are getting three lines for input string, right? We can do it in same line itself. See how we can do is just scanf percent d for n variable, then percentage d for m variable, then percentage d for k variable, right? Here you need to leave these spaces. Okay. Then ampersand symbol n, ampersand symbol m, ampersand symbol k. We are getting 3 input in the same line. 10, 20, 30, right? Same input and output we are getting. Okay. We can reduce the line of writing. So we can code the line like this also for getting the more number of variables input. Okay. Hope you understand this scanf and printf. We will see now operators. Okay. Now we will see about the remaining operator, that is logical operator. So what is meant by logical operator? So logical has three type of operator, that is and, or, and not. Okay. So and represent the ampersand symbol two times. Then not represent symbol is this and not represent this. Okay. So what does this logical means? Logical operators, it is works on two or more condition. Okay. Between two condition it will work. Okay. So it will check like so first we are going to see about the and. Okay. And means what basically? And means if both value true, then the statement is true, right? And works like if it is 1 and 1 only, then it is 1, right? If it is 0 and 1, it is 0 only. If it is 0 and 0, then it is also 0 only. Only both value are true. That means both the value are 1 and 1 only. The output will be 1. So we see one example. If 3 less than 5 and 6 less than 7. Is this true? Yeah, 3 is less than 5, then it is true. Then 6 less than 7, yeah, it is also true. Then here both the values are true, right? Then our output will be true. Okay, or both the values will be true. If 5 less than 3 and 7 less than 8, here this is false because 5 is not less than 3, 5 is greater than 3, right? And 7 less than 8 is true or not true? Here, one false and one true. What does AND operator will do? If both the value is true only, then the output will be true. If the one value is false also, then the output will be false, right? So we will see this in programs. Just understand what is this logical operator. Okay. So this is the basics of AND operator. We will use two ampersand symbol for AND operator, and if the both the values are true only, the output will be true. If a single value is false also, then the output will be false. Okay. So next, we will see about this R. Okay. R means what? Basically, R means if one value is true, then the output will be true, right? If there exists only one true, the output will be true. Only it gets fails when the both values is false, right? See if 4 less than 5 or 7 greater than 8. Here 4 less than 5 is true because 4 is less than 5, right? Or 7 greater than 8? No, 8 is greater than 7, right? So this is false. So here what will be the output? According to an OR operator, the output is true because we have one value as true. So the output will be true. Only when it's get false means 6 greater than 2 or 7 greater than 8. Here this is also false and this is also false. Then only our output will be false. Okay. So this is how basically R works, R operator works. Then we have this not, right? Not means what? It will flip the value, right? If I have given the output as input as true, it will change this to false. If I given our input as condition as false, then it will flip the condition and it will make true, right? If it is 0 means it will flip into 1, and if it is 1 means it will flip into 0. So right, this is basically how NOT works. So this is logical operator. They have three logical operator and or not. So and means it will only true when two condition are true. If one gets failed also, the output will be false. Or means one value is true is enough. Okay. If only two values are false, then it is false. So basically not means it will flip the value. If it is true, then the output will be false. If the output input is true, then the output will be false. The input is false, the output will be true. We will use this logical operator more in conditional statement. We will see conditional statement later. So this is how the logical operator work. See, let me print it. See, for and we want to give two conditions, right? 3 less than 4. It is true, right? And 4 less than 5. Here what will happen? First, it will check 3 less than 4. Yeah, it is true, right? And it will check 4 less than 5. 4 less than 5, right? Then here also it will become true. Then our output, what is the outcome of this output? 2, right? Then we are given here percentage d, right? I have explained you in previous video, right? True means 1, false means 0. So in our print statement, we have got the output as 2. So here it will print 1, right? So let me run this. Okay, understood? This is how the AND operator will work. See, if I given 6 greater than 7 and 3 less than 4, here what will happen? 6 greater than 7, it is true? No, it is false. And 3 less than 4, it is true, right? But we have used and in between these two conditions. So both the output should be true, right? Here one is false and one is true. Then what is our output? We will get false as output. Then 0 will be printed, right? So we will just run this. Okay, the first is true and the second one is false, right? So for we will see for R now. Render percentage D. If 3 less than 4 or y greater than 7. R means what? If one condition is true, then the output will be true, right? So here what we have 3 less than 4, it is correct, right? True. R 5 greater than 7? No, 7 is greater than 5. So this condition is false, so we will get false here. See, one value is true and one value is false. What is our condition? Even one value true, then the entire output will be true, right? So here the output will be true and we will be printed 1, right? See? So wait, we will use slash into slash. Okay, 1, 1, 1. So now we will use R. Okay, okay. We will see. percentage D, 3 greater than 7 or 7 greater than 8. Here, both the condition are false, right? 3 is not greater than 7, then it is false. Or 7 greater than 8? No, 8 is greater than 7. So here also false. Both the output are false. Then what will be our output? Output will be 0 and it is false, right? So here in this we will be printed 1, in this we will be printed 0, in this we will be printed 1, in this we will be printed 0, right? So we run it, right? 1 0 1 0 1 0 1 0. Okay, so we will see that remaining not operator. Printf percentage D not of 0. And okay, first we will run it. Not of 0 means what we want to get? We want to get 1, right? See, we have got 1. Okay, then enter percentage D not of 1, 0. Okay, see here, I'm again giving printf D. Here, apart from 0, if you give any of the number with not 8, 9, 10, any of the number with not, you will always get the 0. Only not 0 will give the 1. Rest of any number you give not, it will give 0 only. Okay, so let me run it. Okay, see 0 0. Any of the number apart from the 0, if you are given not, it will always change to 8. Only 0 only give the 1 value. Okay, so this is about the logical operator we have seen now. Okay, now we are going to learn about the another type of operator, that is bitwise operator. So what is meant by bitwise operator? Bitwise operators work directly on the binary representation of the data. We know that computer only understands zeros and one, right? That is binary values. This bitwise operator will manipulate the individual bits into binary numbers and it will shows us the output. We are using arithmetic operators in numbers and we are going to use binary bits for our bitwise operator, right? So for understanding the bitwise operator, first important thing is we should know about the convention of decimal to binary values, right? So decimal to binary conversion we should know. Okay, so how we are going to convert this? See, decimal means it is the whole numbers, that is 2 3 4 5 6. Binary means it only consists of zeros and ones. Okay, so how we are going to convert this? See, if I given the decimal number as 4, the binary number is 100. Okay, the binary number is 100. How to calculate this? See, for calculating or the conversion of the decimal to binary is, we want to just divide it by 2 until we get the remainder zeros and 1. Okay, so how we are going to do this? See, first we want to divide it, right? So our number is 4, our decimal number is 4. For converting the binary number, we want to divide it by 2. Okay, so what is when we get 4, 2 2s are, we will get 4. Here, did we have any remainder? No. our remainder is 0. Then here we have 2. So again we want to divide it. So again we are dividing it by 2. Then 2 ones are 2. Right? Now our remainder is 0. So from this how we are going to calculate the binary number? From downward to upwards. This number they are right. This number and we have got the remainder and we got the remainder. So here from the downwards to upwards we write 1 0 0. So this is the binary number of the 4. Okay, don't get confused. We will see another example. See, now I have given decimal number as 6. What is the binary value? See, first we want to take that number, right? Then we want to divide it by 2. 2 3s are 6, right? Then we will get the remainder here 0, right? Then again we want to divide it by 2. Now 2 ones are 2, the remainder is 1, right? Now we want to look from downwards to upwards, that is now we will get 1 1 0, right? So the decimal number with the base 10 with the base 10 right, I will write it. So this 6 with the base 10 is equal to 1 1 0 in binary. Okay, so we will solve another conversion. So now I am taking decimal number as 9 and let me see how to do this. So first we want to take that number, that is 9, and we want to continuously divide it by 2, right? So 2 4s are, we will get 8. So here we are getting 1 as remainder, right? Then again we want to divide it by 2. Then 2 2s are 4. We will get 0 as remainder, right? Then again we want to divide it. We will divide it by 2. Now 2 ones are 2. We will get remainder as 0, right? Now we want to look down to up. Now what will our value? 9 in decimal is equal to 1 0 0 1 in binary. Understood? So now we will understood this conversion, right? So this is how we are going to convert the decimal numbers to binary numbers. Okay? So now we are going to see about the types of bitwise operator. So in bitwise operator, we have types of, we having like and, or, not, and XOR. These are the types of operator we have in bitwise operator, right? So now see, and means and gate, right? We have and represent the missing symbol. So and means what? When both the value true, then only the output will be true, right? So the truth table is we are giving one value, we are giving two value, and A and B means what we will get. If I am giving A 0, B 0, and the N will be 0 because 0 and 0, 0 only. Then 0 and 1, then what is the output? 0 is the output. Then 1, 0, what is the output? 0 is the input. Only 1 and 1 is 1. Okay? Both the values should be true. Then only the output we will get the true. Okay? This is the bitwise AND. So how we are going to check this? See, we are going to take two numbers and we are going to AND it. Okay? So I am taking n equal to 12 and m equal to 10. Okay? Now, first what is the rule? First we want to convert them to binary numbers, right? For converting binary numbers, so we are going to do, we are just going to divide it by 2. First I'm going to divide 12. So 2 6 are 12, remainder is 0, and again 2 3s are 6, the remainder is 0. Then again doing with 2, 2 1s are 2, the remainder is 1. So we want to look from down to up. Then for 12, we will get 1 1 0 0, right? Then again for 10, we want to give the binary number, that is 10. Want to divide by 2. So 2 5s are 10. Remainder we will get 0. Then again we want to divide it. Now 2 2s are 4. The remainder is 1. Then again we want to divide it. 2 2s are 4. The remainder is 0. Then again we want to divide it. 2 1s are 2. Now our remainder is 0. Right? So we want to look from down to up. That is for 10, we are getting 1 0 0 1 0. Okay, so now we are speaking about the convention of 12 and 10, right? So first we want to convert this into binary number, right? So first I'm taking 12 and we want to divide it by 2, right? Then 6, 2 6 are 12, then our remainder will be 0. Then again we want to divide it by 3. Now 2 3s are 6, the remainder will be 0. Then again 2 1s are 2, The remainder is 1. For getting the binary value, we were looking from down to top, right? So our binary value for 12 is 1, 1, 0, 0, right? So now for 10. 10, we want to divide it by 2. 2 5s are 10. The remainder is 0. Then again we want to divide it. 2 2s are 4. The remainder is 1. Then again we want to divide it. 2 1s are 2. The remainder is 0. Right? So we want to look down to upwards. Then for 10, what is the binary value? We have 1, 0, 1, 0. Now we have got the binary value, right? So we want to add it. Okay, now we are going to perform the AND operator. Okay, so 0 plus 0, sorry, in AND operator 0 and 0 means 0 and 0 we got 0, right? 0 and 1 what we have got? 0. Then again 1 and 0, 1 and 0 we got 0. Then 1 and 1 we got 1, right? Our final value is 1000. Okay, so now we have got our answer in binary value. So how we are going to convert this in decimal value? Okay, so first take our output value, that is now we are going to see the binary to decimal conversion. Okay, so we are 1000 as the value. Okay, what we are going to do? We are going to see about the binary to decimal condition, because we have got our output as 1000, so we want to convert this into decimal and see what is our final output. So how we are going to convert this binary to decimal number? So we have our output value is 1000, right? So in binary we have this bytes, right? Sorry, bits, that is 8 bits a binary number has, right? 8 bits a binary number has. So you should remember this bits. So our binary number is 1000, right? So how to convert this in decimal? So starting from this last position, this first bit will become. Okay, so here 1, here 1, here 2, here 4, here 8. Okay, understood? For 1 it is 8, for 0 it is 4, 0 2, 0 1. So right to left it is going. Okay, now find in our binary number where there is one position, calculate and add that bit. So here in our binary number we just having only 1 1 1. So we having the state value it is 8, right? So for this our decimal value is 8. For 100, sorry, for 1000 the decimal value is 8. Okay, Don't get confused. We will see another example. See, for I'm taking one random binary number is 1011. Okay. So we should now calculate the decimal number. So what is our first bit? First bit is 1. Then we have 2. Then we have 4. Then we have 8. Right? So now see. This is our binary number. Okay. This is our binary number. This is our bits. It's our bits. This is our binary number. So check where are the one not presents. So here we have at first bit we have 1. So that corresponding value is 1, right? So first add 1, 1 plus. Then we have second bit also 1. So that corresponding value is 2, right? So add 2. Then we have the third bit as 0. So we won't consider that. Then we have fourth bit as 1. Again it is 1, right? So the corresponding bit value is 8. So we will just add here 8. Now add all. 8 plus 2 10, 10 plus 1 11. So the decimal value for this binary number is 11. Okay. For our decimal binary value, the decimal value is 11. Okay. Okay. We will see another example. 1001. We will see. This is our binary value. So first take binary value, then give its corresponding bit value, right? For starting from 1, 2, 4 and 8, right? Okay. Now we want to see in our binary bit at which position the 1 is present. So in our first position the 1 is present and the corresponding value bit is 1, right? So now we will add it 1, then plus. Then the second bit is 0. So we won't add that. Then our third bit is 0. Our fourth bit is 1, right? Then its corresponding value is 8. Now we will add 8. Then it is equal to 9. So our binary value 1001 decimal value is 9. Okay? Understood, right? So now in our example this, we have gotten 1000, right? So how we are going to calculate this? 1000, right? Then the corresponding bit value is, we have last in 1. Then 2 at second position, 4 at third, 8 at last. Okay. Now see. The first bit is 0, second bit is 0, third bit is 0. Only the last bit is 1. So what is the corresponding bit value? 8, right? So for decimal value of 1000, sorry, the binary value of 1000, the decimal value is 8. So when we are doing when we are doing 12 and 10, we will get the answer as 8. Okay, hope you understood. We will solve some something. Don't worry if you not get understand. We will solve some based on this. Okay, it will works on the truth table only. So you need to understand clearly decimal to conversion, binary to decimal conversion, and this truth table values. You should understood. Okay. Okay. Now I hope you understood that AND operator. Now we are going to see bitwise OR operator. So this is the symbol of bitwise OR operator. So first we want to know about what is bitwise OR operator, right? OR means OR gate means what? If one condition is true, then the output will be true, right? Even the single bit is 1, the output bit will be 1 only, right? Like A, B, and our output, right? 0, 0 or 0 means the output will be 0. 0 or 1 means the output will be 1, right? If 1 and B is 0, then also the output will be 1, right? If A1, B1, then the output will be 1. So this is the logical gate for R. Okay. So I hope you understood the decimal conversion and binary conversion. First, we are going to take one example. I'm taking n equal to 7 and m equal to 6. We are going to perform the OR operator in between this. Okay. So the question looks like 7 or 6, right? So first we want to find the binary number of 7 and 6, right? So 7, 2. 2 3s are 6. The remainder will be 1. Then again 2 ones are 2. The remainder is 1. Now down to up for 7. That is binary value is 1, 1, 1. Right? So now we are going to find it for 6. 2. 2 3s are 6. Remainder is 0. Now 2 ones are 2. The remainder is 1. We want to check it from down to up. Then for 6, our binary value is 1, 1, 0. Right? So we want to do R in between this. Right? R. So what is 1 or 0? 1. Right? 1 or 1? 1. 1 or 1? 1. Right? So this is our final binary value. We have to convert it to decimal value. Right? So the decimal value just 1, 1, 1. Take it. Okay. Then their corresponding bit value. First starting from 1, then 2, then 4. Right? Then we just want to calculate in our binary number where and all present 1 bit. Right? So first we have 1 and the corresponding bit is 1. Then plus. In second positions also we have got 1. So plus 2. In third position also we have 1 bit. So plus 4. Now if we add it, we will get 7. So the output for 7 or 6 is 7. Okay. We will see another example. Let's take n equal to 12 and m equal to 11. Okay. First what we want to do? We just want to find the binary value, right? For 12, 2 6 are 12. The remainder is 0. Then 2 3s are 6. The remainder is 0. Then 2 1s are 2. The remainder is 1. We want to look from down to up. Then for 12, our binary value is 1 1 1 0 0. Right? Then for our 11, 2 5s are 10. The remainder will be 1. Then again divide. 2 2s are 4. The remainder is 1. Then again divide. 2 1s are 2. The remainder is 0. Down from upward. Then our 11 decimal value is 1 0 1 1. Right? Now we just want to do the OR operator here. 0 and 1 1. 0 and 1 1. 0 or 1 1. 1 or 1 1. Right? So we have got 1 1 1 1 as our binary value. Now we want to convert into decimal number. So 1 1 1 1. Right? Our corresponding bit value is 1 2 4 then 8. Right? So now calculate. Here we have all the bits as 1. So we want to add all this value, right? 8 plus 4 plus 2 plus 1. What will be the answer? 15, right? So for our question, 12 or 11 is 15. Okay. So this is our bitwise OR operator. Hope you understood. If you have any doubts, let me see in the comments. Thank you for watching this video and give us one like and support for more video and subscribe. Okay. Now we are going to see about the CXM. Okay. Represent this. Okay. XR truth table is A, B, and C. XR will give 1 as output when the bits are different bits. Okay. Like if 0 and lowercase bit and higher case bit, it will not give the true value. It only gives the true when the two bits are different bits, right? So 0 0 will get 0, right? If it is 0 and 1, we will get 1. If it is 1, 0, we will get 1. If it is 1, 1, we will get 0. Okay? This is the truth table for XOR. Now we will see one example for this XOR. Okay? First, n equal to, we will take 5. M equal to, we will take 8. Okay? First, what we want to do, we just want to convert them into binary values. First for 5. Okay? So, 2 2s are 4. The remaining is 1. Then 2 1s are 2. The remaining is 0. We want to look from down to upward. For 5, it is 1 0 1. Right? Now for 8, 2 2 2s are 4. Sorry, 2 4s are 8. Remainder is 0. Then 2 2s are 4. The remainder is 0. Then again we want to divide it. 2 1s are 2. The remainder is 0. We want to look from down to upwards. Then for 8, we will get 1 0 0 0. Here we have 4 digits, here we have 3 digits. Don't worry, just add 0 before it. Okay. Now we want to do XOR between them. Okay. 1 XOR 0, 1. 0 XOR 0, 0. 1 XOR 1, 0, 1. 0 XOR 1, 1. So our final binary value is this. Now how we are going to convert this? Just we have our binary value 1 1 0 1, right? So our corresponding bit is 1 2 4 8, right? So where and all we have first bit we have 1. So we will first add 1 plus second bit we have 0, third bit we have 1. Corresponding value is 4. Then plus add. Then fourth bit we have 1, corresponding bit value is 8. So add it. Now what we will get? We'll get 13. Right? So our answer is 5 XOR 8 is 13. Okay? Hope you understood this. Then we are going to see about the bitwise NOT. Now we are going to see about bitwise NOT operator. Bitwise NOT operator, the symbol is this. Okay? So for this, the truth table is A and the output. If I give 0, the output will be 1. If I give 1 as the input, and output will be 0. 0. It will flip the number. That's it. Okay. So what does the bitwise NOT will do? So I am taking int n equal to 5 and I am storing in int m equal to not of n. Okay. So what here will happen? First, for 5, the binary value is 101, right? So this NOT will works in 32 bits. That means 4 times 8 bits, right? So in between 5, and then 0 0 0 0 4 5 6 7 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. So it will looks like this, our 5 binary value. Then if we do not of this binary value, we will get 0 means 1, right? 1, again 1 1 1 1 1 1, then again 1 1 1 1 1 1 1 1, right? Then again 1 1 1 1 1 1 1 1, then 1 1 1 1 1. After here we have 1, so we should give 0, then again 1, then 0. So if we convert this number, we will get the -6 as our output. How means? We have one formula to calculate this NOT operator bitwise. That is, we are giving m equal to, in m it will store NOT of n, right? So what it will happen? It will give minus of n plus 1. So this is the formula to calculate the NOT operator. Okay. So if I give n equal to 6, then the NOT of n equal to -7. Okay. So this is how we are going to use NOT operator. So now we are going to see some problems based on the bitwise operator and or not XOR. Okay. So first is bitwise and, okay. So first we want two numbers, right? So first int n comma n. We are getting two numbers and we are going to perform AND operator in this two variable. So first I am going to get the two variables, address of n, then address of m. Okay. Then in one integer k, I am going to store this value n and m. Okay. Now I am just going to print it, %d comma k. Okay. So what will happen here if I give 4 comma 5 in this line means it will goes to this line. Then 4 and 5 means, for 4 what is the binary value? 100. For 5 it is 101, right? So if you perform AND means here 1 and 1 0, sorry 1, here 0 0 0 0 1 0. Then 100 means we will get 4. Then here we will get the output as 4. Okay. So let me run it. So okay, 4 5 4. Okay. You understood? So we will try for another number like 3, and we will do for 6. Okay. So here it will 3 and 6, right? For 3 it is 11. For 6 it is 110, right? If we do, then here it is 0, here it is 1, and here it is 0. 10 means we will get 2. right? So in the output, we will get 2. 3, 6. We have got 2, right? So this is how the AND operator is working. So now we will go for bitwise OR. Okay. So for R also we need to get 2 integer, right? If we take int m as int k comma l, and we are going to get it through scanf, right? What is the following specifier? Percentage d and another percentage d comma address of k comma address of l, right? So in one integer we are storing k r l, right? Sorry. Then we are just going to print it. Percentage d comma t, right? So what will happen here? If I give 5 comma 6 in our input, then in this line it will come, it will do the operation 5rx. What is the 5 binary value? 101. What is the 6 binary value? 110, right? If we perform operator for this, it will start from right to left, right? So 101, then 011, then 111, right? So 1111 means we will get 7 as output. Then in our output it will printed 7, right? So let me run it. 5 comma 6, 5, 6, 7. Okay, we have got our answer 7. If I give like another value 3, 2, we have got 3. How? Now 3, 2, right? So here it will perform 3 or 2. What is the binary value of 3? 11. What is the binary value of 2? 10. If we perform OR operator, here 1 and 0, 1. 1 R1, 1. Right? So it is 3. Okay? Hope you understood. Now we will see for bitwise XOR. Okay? So for this also you want 2 input, right? So int R comma T, then scanf I am getting input R comma and right, then it's equal to R XOR T. Then I'm just going to print it percentage D H, right? So if I give here 6 and 7 in this line, it will just do 6 or 7, right? 6 XOR. So what is the binary value of 6? 110, right? Then for 7, it is 111. Then if we do XOR means, what is the XOR condition? If both the value are different, then only it will become 1. So 1, 1, it is 0. 1, 1, it is 0. 0 XOR 1, it is 1. So the value is 1. Okay, so it will print it 1 here. Let us run this. 6, 7, right? We have got 1. Okay. So now we are going to do for bitwise not. Okay. For not, we just need only one input. That is int n. We are getting it in scanf and n, right? Then we are storing it in another variable, not of n, right? Then we are just going to print it percentage d m. Okay. So now I am giving 5 as input. Here, this line, what the formula taught us minus of n plus 1, right? So that means minus of 5 plus 1, we will get minus 6 as output. So here, the output will be minus 6. Okay. If we run this, 5, 6. Okay. If I give 7, the output will be minus 8. Okay. So this is for not bitwise operator. Hope you understood this sums and explanations. Thank you for listening. We will see you in next video. For more updates, connect with us and subscribe our channel for more information and daily updates. Okay.